2.1c is on exponents. So to warm up, we want to simplify the expression 3 squared. 3 squared means we have 3 2 times, so it means we're taking 3 and multiplying it by itself. 3 times 3 is 9. So example 1, let's look at the definition of an exponent. The exponent of a number says how many times to use that number in multiplication. How many times to use that number in multiplication. It's written as a smaller number to the right and above the base of the number, or we also call that a superscript. So our exponent is that little number that's written above and to the right, and then the base, that's what we're going to multiply by. So if we have 8 squared, or 8 to the second power, that means we're taking 8 and multiplying it by itself twice. So the exponent 2 says to use the 8 2 times in multiplication. And we know that 8 times 8 is 64. Example 2, we want to identify the base and exponent of each and then expand each expression. So 6 to the second power, 6 is the base, and 2 is the exponent. 8 to the fourth power, 8 is the base, 4 is the exponent, and then C52 is the base, 7 is the exponent. So the base is what we're multiplying, the exponent is how many times we're multiplying it. So 6 to the second power says we're taking 6 times 6. 8 to the fourth power says we're taking 8 times 8 times 8 times 8, 4 times. 52 to the seventh power says we're taking 52 and multiplying it 7 times. So that's 3, 4, 5, 6, 7. This is expanding, writing out what it actually means. That's expanding it. Example 3, if we wanted to write 5 squared in words, we could say it is 5 to the second power, or we also call that 5 squared. Anytime something is to the second power, we can call that squared. So if we wanted to expand 5 to the second power, that means we're taking 5 times itself, which would be 25. Example 4, we have 4 to the third power. In words, right, we would say 4 to the third power, or we could also say 4 cubed. Anything that's to the third power, we can also refer to that as cubed. So 4 to the third power, if we wanted to expand this, it means we're taking our base 4 and we're multiplying it by itself 3 times. 4 times 4 times 4. Example 5, it'd be a good idea to pause and try this one on your own. 2 to the fourth power. Well, we would say 2 to the fourth power. So if we wanted to expand this, that would be 2 4 times 2 times 2 times 2 times 2. We also call the fourth power quartic, so we could say, but we're just going to refer to it as the fourth power for now. So example 6, try these and explain the difference. Well, 2 to the sixth power, our base is 2, our exponent is 6. So we want 2 6 times. 6 to the second power, our base is 6, and our exponent is 2. So this means we want 6 twice. Okay, so these are very different. If we multiply 2 by itself 6 times, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the sixth power is 64. 6 times 6 is 36. So, right, even though the numbers are the same, there's a very big difference between having a base and your exponent, right? It matters which one is your base, it matters which one is your exponent, because it tells you what is being multiplied and how many times it's being multiplied, so it makes a difference. Exponents with negatives. Sometimes we have negative numbers in exponents. So, do you see how there are parentheses around this? So this is saying we've got negative 2 raised to the second power. So it's saying we want to take negative 2 times negative 2. Well, negative times negative would give us a positive 4. Okay, negative 2 cubed, well, then we have those parentheses around negative 2. It's saying we're taking negative 2 3 times. So negative 2 times negative 2 would be positive 4, and positive 4 times negative 2 is negative 8. Notice that when we had an even number of negatives, we had a positive answer. When we had an odd number of negatives, we had a negative answer. That should always happen. Now these next two are a little bit different because they don't have parentheses. So this is actually a negative times 3 squared. In other words, we can think about it as a negative 1 times 3 to the second power. So really only the 3 is raised to the second power. The negative is not. So this would really be negative 1 times 3 times 3. Well, 3 times 3 is 9, so this would really be negative 1 times 9, which is negative 9. Same with our negative 5 to the third. Again, it's not in parentheses, so the negative isn't to the third power. This is really like having a negative 1 being multiplied by 5 to the third. Since it's 5 to the third, we only have negative 1 time, but we have 5 3 times. 5 times 5 times 5 is 125. So we really have negative 1 times 125, which is negative 125. All right, so that's our exponents. Make sure, the bigger number is always the base. The smaller number raised to the right is the exponent. That's telling you how many times to multiply something together.